Have you ever wondered how economies continue to expand and generate more wealth, even when they seem to have reached the limits of simply adding more workers or machines? Well, a crucial concept for understanding this is total factor productivity, or TFP, which is calculated as a residual. This means TFP represents the portion of economic growth that cannot be explained by increases in traditional inputs like labor and capital. Think of it this way. Economic output, like a nation's gross domestic product, is produced using inputs. The primary inputs we usually consider are labor, such as the number of hours worked by employees, and capital, which includes things like machinery, factories, and technology. Many economic models, such as the well-known Cobb-Douglas production function, describe output as a function of these labor and capital inputs, plus a factor for total factor productivity. So, if we measure how much output has grown, and then account for how much of that growth came from having more labor and more capital, whatever is left over is attributed to TFP. This residual captures the impact of various factors that make labor and capital more productive. These can include technological advancements, improvements in management techniques, the education and skills of the workforce, which is often called human capital, and even the efficiency of a country's institutions or regulatory environment. TFP essentially measures how efficiently and effectively these traditional inputs are being used to produce goods and services. The practical approach to calculating total factor productivity is often referred to as growth accounting. It involves breaking down the observed growth in output into the contributions from growth in labor, growth in capital, and the residual, which is TFP. First, you measure the rate of growth of total output, usually real gross domestic product. Then, you measure the growth rates of labor input and capital input. Each input's growth rate is weighted by its share in total income, typically its average share over a given period. For example, if labor receives 2/3 of national income, its growth contribution is 2/3 multiplied by its growth rate. Once you subtract the weighted contributions of labor and capital from the total output growth rate, the remaining growth rate is your estimated total factor productivity. This requires robust data on these economic variables. Interestingly, total factor productivity is sometimes called the Solow residual, named after economist Robert Solow, who pioneered much of this analysis. It is a powerful concept because it distinguishes between growth that comes from simply accumulating more resources versus growth that comes from doing things better or smarter. For instance, discovering a new energy source or inventing more efficient production methods would boost total factor productivity, driving genuine progress. This makes it an incredibly insightful metric for understanding long-term economic dynamics and for policymakers seeking to promote sustainable development. In essence, while labor and capital are foundational to production, total factor productivity is the hidden engine of innovation and efficiency. By calculating this residual, economists can better understand the true sources of a nation's prosperity and identify areas where technological progress and improved resource allocation are truly making a difference, paving the way for sustained economic advancement.